Hello everyone, welcome back. We are ready to start the next session, still about the international experiences with digital building permits. And now I introduce you José Granja from Portugal, University of Minho, who will present the concept for process towards automated building permits in Portugal. So please, José, the stage is yours.
Okay, let me just share my screen. Yes, I think it's been shared. So, hello everyone. My name is José Granja. I'm sorry to be presenting you that will be back in the past because you saw a lot in future in the last presentations. So, but this will be more or less the reality that we have in Portugal. So, I will be talking a little bit on concepts for the processes towards automation of building permits in Portugal. So, as we already spoke a lot about this, there is a very big interest worldwide for the automation of building permits, and in recent years, a lot has been done, especially with the open source formats that are enabling the push towards a more automated digital building permits. However, in Portugal, some years ago there was no efforts yet. We were still in the transition between paper to digital formats, even in the traditional drawings for the building permits. There are still municipalities that are still in that transition, and there is no full transition for digital from paper. But now we wanted to evaluate the possibility to push to a fully automated digital building permits. So the first approach that we performed was a case study some years ago, where we looked to one of the national regulations that were that I will be speaking a little bit after, to check how can we put automatic verifications from this regulation. The first approach was to use Solibri model checker. Later we thought that this is not a good approach, but this was the first approach. And we had a case study of a small house in the municipality of Vila Nova de Gaia. So first thing, we looked to our national code. It was the general regulation for urban buildings. And we went through all the regulation to check what articles of this regulation could be automatically verified or not. It means that is there a way to program the rule in a simple programming, not like going to artificial intelligence, because we have a lot of rules that are not yes or no. It's very gray, and it needs a human to interpret the rule. So we went through all the articles, and we found that more or less half of the articles we were able to implement in an automatic verification, even if it's in just some parts, because some others it might need a human hand to fully verify that regulation. And from the overall articles, we found that we had 140 rules to verify. Then we picked that rules and we went to Solibri model checker, and we checked how many of them could we implement without going to the programming inside Solibri to see what could we be done with the already available tool. And we found that from this 140, only 55 could be implemented directly in Solibri model checker from this regulation. And then we picked this implementation that we did in Solibri model checker, and we went to this case study and we ran, and only 15 rules applied from this 55 to that case study, because this was a small building, and that regulation is very general. It's for the entire buildings, types of buildings. and this was just a small house. There was a lot of articles that were not included because there was no meaning to verify them. But then we were very excited, even if it was a preliminary study. And then we start thinking about how should we go further on this. And we look to that we should look to the entire set of rules. For example, in the Gaia municipality, we have 3 more rules that are not national, but they are at the municipal level. That you have the municipal regulation for your urbanization and buildings. We have the municipality master plan, and also more specific rules that for some neighbors, they have specific rules. And we wanted to go for a more open source solution and to implement algorithm-based verifications as Solibri, but more open source, in a more open source way. We had some experience working with Beam Vision. It's not completely open source, but it enables us to implement coding in the API. So our approach was to go to a completely open source file with the IFC, and we wanted to implement some rules, some modeling rules for designers that with the minimum impact on their workflows, but for us to be able to automatically run verifications. Of course, we know that there were some rules that were not possible to go for verification with the current regulations, and this is an issue in Portugal, and we are working on it to see what we can do with that kind of regulations, which we might be able to change or not. But despite the fact, we went through the next step. So we went to Beam Vision. We started implementing some plugins with coding in C#. For example, in here it was for an article for verifying the topology of each fraction inside a building, and this was relatively easy to implement because the rule was very specific, and we went through. And then also we set some workflows for the overall approach of the digital building permits. We had 2 different workflows, one for the designers and one for the side of the municipality. And this was our thinking of how this should work. So from the designer, we wanted for him to receive from the municipality all the modeling rules, and also, if possible, to deliver the digital twin of the neighborhood of the building for him to be able to perform the design based on the rules, and to export to the open format, the IFC format, and to check automatically if this IFC has some problems already or not, or if it's completely correct for submission to the digital building permit. So then, from the side of the municipality, after that verification, the municipality will receive a more proficient IFC, and it will run a semi-automatic. We will not call it fully automatic, because in our opinion, it should be a semi-automatic rule checking, because in the end, the results will always be checked by a person to be all the rules that are not automatic, or even to check if even in the automatic verifications, if this is compliant with the philosophy of the municipality. And of course, if this is okay, it will be approved, the project. If it's not, it will be sent back to the designer, a report based on a BCF format for him to correct the problems with design. We went again through all the codes, and we start to classify all the rules and to check what different types or methods of verification do we need to use. And until now, we already came out with some types of methods. Here is a sample of them. For example, in terms of verifying distance, horizontal, vertical, in terms of verifying topologies or verifying spaces and properties of spaces, verifying the stories of the number of stories and story heights and so on. And of course, if we have spaces inside other spaces, to make some kind of verifications with that method. Then we went through all the codes and we check what is the rule that we need to verify and how should we implement this rule in terms of that simple methods and types of verifications. And we were able to, in a not very complicated way, to check a lot of different rules, not the entire set, but some of them that we looked with a very low impact in the modeling, in the changing the way designers model their own buildings. And then we implement all of this inside the Beam Vision. We implemented some articles from the regulations in Portugal. But in the end, despite the fact that we were very successful, and we presented this already to 2 municipalities in Portugal, we found out in the end that probably we should not be using Beam Vision. We are now changing for a completely open format, because even if we could do this in an academic approach freely, if we go to the municipality part, we need to switch to a completely open format. And this is the point where we are. We are now going through fully open source, and we believe, as Tonya presented, that this should also go online for an online platform, not only being in a standalone application. Now, I would like to thank all of you for the time.
Thank you very much, Jose. So now it's open for questions. In the meantime, I ask a question myself. Yes. In your opinion, the check would always be semi-automatic, or can you distinguish between different kinds of regulations that need different approaches?
Yeah, it might be the case, because some regulations are easier to adapt than others. For example, the regulations that are from the municipality, probably when we start working with them, we'll be able to switch a little bit the request from the regulations to enable us to create a fully automatic verification. But the ones that are more at the national level, for me, I believe that for several years to come, it will still be semi-automatic. And even, for example, if we look to some regulations, it still needs human interaction, because sometimes it's not a yes or no question, it's more a political question, and it needs a politician to take the decision.
Okay, thank you. Are there any questions from the audience? So I will make one more. How are you considering the possible errors that you could find in the data, whether using them at the moment of using them for the checks?
Our thought about that, if for example we receive not efficient IFC files that are not structured the way we want, is that it will need to have a parallel track. The first verification when the file enters the system will be to check if it's compliant. If it's not, in my opinion, in our opinion, I think we should ask a question to the designer. That is, do you want to still submit the file like that, or you want to replace? And if he wants to submit, it should follow a more manual approach. But we cannot set that everyone needs to follow that, because we need to put in the national law that if you are designing, you should follow this. But this is really hard, and even in Portugal, I cannot forbid someone to submit right now a design that is not in BIM. It's still in CAD. So this parallel track needs to still exist. It's just we will probably sell, like, if you submit in this format, your permission will be 50% faster or something, and this is a selling point for pushing everyone to comply.
Okay, thank you, Jose. I have there is one more question in the chat. Okay. Could you please clarify why BIM vision was not appropriate for municipalities?
It's just a question of spending money, because if you want to set the plugin to be used several times, it costs some money. It's not full, and is not fully open source, because you don't control you just control the API, not the entire software. And also, because we want to change to web-based, we cannot use that software.
Thank you very much, Jose. Now we can switch to the second speaker of this session, who is Ferrol also from the Lund University, and he will present the exchange of digital information in the building permission process in Sweden. So some previous and possible future studies. So Ferrol, the stage is yours.
Yeah, hello. I will stop sharing my screen. Yeah, wait till something shows up. I'll present some works that Lars Harry and I have been involved here in Lund, and some ongoing projects in Sweden. So it's a bit of all projects we have done, and then more an overview of what is currently happening. Both Lars and I have a GIS background, so we have mainly been working with GeoBIM and standardization of geodata to support exchange of digital information. It takes time for the presentation to show up.
We are seeing your presentation, Ferrol.
Yeah, it just popped up here also, so that the workflow that we've been working with is similar to what many or most are working with. In our case, we've been working mainly with the planning and design phase, the building permit application, and updating a 3D city model with an as-built BIM model when the building is constructed. The first part is the planning and design phase. Today, the required geodata for planning and designing a building are usually delivered in 2D from the municipality and in a local information model. There's not really a well-established standard for municipality base maps. So the one requiring data could get different types of data depending which municipality they're getting the data from. In addition to the municipality base map, also need a detailed development plan. That's where the rules and requirements of the area are given. The detailed development plan is often a digital format, but it's not with machine-readable rules and regulation. And the rules and regulation are often local, decided by the municipality. So it's hard to make something automated. So the plan is to have all development plan in machine-readable format, and that all geodata that are required are available in a standardized format from a geodata service. So anyone that plans for a new building should be able to retrieve the required geodata in IFC formats from the service, and that way it will be easy to import the data to a BIM environment for designing the building. And that includes also the detailed development plan. The designer then designs the building and submits the building permit application. The building permit application often consists of a situation plan, which is a map with information about the planned location of the building and the surroundings. The application also includes the detailed drawings of a building in 2D. And usually both the situation plans and the drawings are delivered in CAD, PDF, or image format. In some cases, BIM models are included, but there is no standard of how the BIM model should be structured. So the plan is to have guidelines that states what objects and information that needs to be included in an IFC model when it is included in the building permit application. The process of actually checking the building permit application against the national building rules and the rules and regulation in the detailed development plan is a manual and time-consuming process. We have done some studies with semi-automated compliance checking as demonstrations. Then, in the final stage, when the building is constructed, the geodatabase needs to be updated. Then we want to use an as-built BIM model, and they are sometimes delivered to the municipalities when the building is constructed, but very few municipalities can actually use the BIM models. So the plan is to be able to use the as-built BIM model to automatically update the geodatabase.
Oh, sorry, Pavel, we don't see that you're changing the images.
Yeah. So what have we done this far? What is currently happening in Sweden? So one project we have been involved with, a project where we studied the possibility to create an unbroken digital data flow in the built environment process, following the workflow in the previous slide. There, as I mentioned, the first step is to import the geodata and the detailed development plan in IFC format to a BIM environment. And that proved to be quite tricky because the BIM environments we tested were sensitive to geometries. And there were a lot of point and line objects in the geodata that were not well handled by the BIM tools. And there is currently an ongoing work to develop national specification for geodata that's led by Lantmäteriet, which is the Swedish Mapping, Cadastral and Land Registration Authority. And the aim is to have a national standard for geodata, so that data that are delivered from the geodata service is in the same format, no matter what municipality that the data is obtained from. That will make it easier to convert the geodata to IFC format. When it comes to the detailed development plan, there is a recent digital standard. It's established in 2016 to support machine-readable development plans. The standard defines which building regulation types that are allowed in the plan, but it's not easy to translate already existing detailed development plans to the new standard. But we did an inventory of the rules and regulation in the new digital standard. We estimated that around 85% of the regulations will be possible to check with automated methods if we have BIM and geodata available. And there is a new legislation that from 2022, all new detailed development plans must follow the new digital standards, which means it will be easier to automate the code checking. There's also ongoing work to develop guidelines for information content in BIM to support automated compliance checks based on BIM models. So IFC is, as you know, a very flexible standard. And the plan is to define model view definition that states what objects and what information that is required in the BIM model that is used when applying for a building permit. And we have done some tests with automated rule checking, or rather semi-automated rule checking. And we have used IFC models, geodata, and detailed development plans according to the new digital standards. And we have checked rather simple regulations related to geometry, such as building area, building heights, if the building is an allowed location, and if there are enough available parking spaces, etc. And we have done all tests in FME, where we import the data, we perform the tests and generate a simple report in Excel format and also visualize in FME. So on the center part of this slide, you see a test where we tested building height. And in the top, the building is within regulations, so it's okay to build. The bottom building, the building is too high, so we get a red warning and the red plane that shows this is the maximum allowed height of the building. Then the final step in the workflow is to update the geodatabase with the as-built IFC model. And again, there are guidelines for information content in BIM, and there will be guidelines also to state which information and objects that are required in the as-built IFC model to update the geodatabase. In the ongoing work to develop national specifications for geodata, as I mentioned, one part is about building. So there will be a national information model for buildings. That's also developed by Lantmäteriet. And we are also involved in a project together with the 3 largest cities in Sweden that hopefully will be the base for a national standard for 3D city models. The work we're doing is based on CityGML, and we're working with information modeling and measuring and modeling guidelines. And we have done some tests to update geodatabases with IFC models. We converted IFC models for different buildings to 3D geodata in CityGML format, and we compared it with 3D building models that were created from LiDAR data. And the geometries of both building models, the one from IFC and the one from LiDAR, agrees well. One important finding in the study is that modeling guidelines are really important when we want to convert the IFC models to geodata format, because it's so much information in the IFC model. So what should we expect? How large should objects be to be included in the geodata model? Yeah, that's all for this presentation.
Thank you, Perola, for your presentation. Are there any questions? Please type them in the questions tab if you can, but I think that I hope at least that only Jada had a temporal issue with it. I could see very interesting works from many countries, and it's interesting to see how the patterns and the tackled problems are very common, and how there are slight differences in also in the way governments and municipalities are supporting it. And that was really a nice overview of the ongoing works. Oh, we have one question. Data provision for terrain and building plans. Are they all provided by one public entity, or is it more distributed?
Well, the plan is to have a national geoportal that's handled by Lantmäteriet. So it will be possible to get the data from there, but it doesn't mean that all data are stored there. So the municipality, if they want, they can deliver the data to Lantmäteriet, and the data will be accessed that way. But the data could also be stored locally, but it will be accessed via the one entry point, your portal. So,
thank you, Perla, for your answer. What is the biggest obstacle in Sweden that can delay or prevent the full digitalization of building permitting process in the near future, in your opinion?
Well, I guess it's not the municipality. They are allowed to define their own rules and regulations, so it's very flexible in that sense. It's not like a national standard that decides the rules and regulation or the format of the geodata. So it's a lot about standardization to have a common format. And then also the old data development plans are a bit hard to translate to the new regulations. So it's quite a lot that it's the differences between the municipalities that make it hard to automate.
Well, I could make a comment to this as well, to add. I agree with what Paola said, but there is also one additional thing that is kind of urgent, and that is who has the responsibility actually to describe these delivery specifications and so on. And that is not clear on a national level, which makes it tricky.
Yeah, that's a good point. Another question that I had was if a national agency that has the full responsibility of it would be realistic, in your opinion, or this kind of responsibility would need to be more distributed also on the land, and maybe they need also different institutions to manage them. Are there any other questions? So we finished perfectly in time. Thank you very much to the speakers for being perfectly timing. And I can close this session, and we go to the following one. That is the first one, dealing with the processes. And thank you very much.